What if the greatest engineering feats in human history are impossible to recreate with modern technology? The official story is simple. Ancient peoples built impressive monuments, but compared to our capabilities today, their achievements pale in comparison. We have cranes that lift thousands of tons, precision tools, computer modeling, advanced materials. We can build anything they built, and better. Except that's not quite true. Scattered across the globe are stone structures that modern engineers openly admit they cannot move. Megaliths weighing hundreds of tons, some over 1,000 tons, transported miles from quarries, lifted to impossible heights, fitted together with tolerances that rival modern machining. And nobody can explain how. Engineers have attempted to move these stones using every technique available. They've failed. The mathematics don't work. The logistics are impossible. The precision can't be replicated. Yet, somehow, ancient peoples accomplished what we cannot. This isn't speculation. This is documented fact. Engineering firms have been hired to move specific megaliths for preservation or study. They've concluded it can't be done safely with current technology. That raises uncomfortable questions. What techniques did ancient builders possess that we've lost? What knowledge was forgotten or deliberately suppressed? Why does mainstream archaeology refuse to seriously investigate these anomalies? Today, we're examining 10 ancient megaliths that are too heavy to move with modern technology. Stones that weigh more than the largest mobile cranes can lift. Structures that defy our understanding of ancient capabilities. Each case presents physical evidence, documented weights, failed modern attempts, engineering assessments, admitting defeat. Fair warning, this evidence contradicts the comfortable narrative of constant human progress. It suggests ancient peoples possessed capabilities we've yet to recover. But the stones don't lie. They're still there, still impossible, still challenging everything we think we know about the past. The evidence speaks for itself. Question is whether we're willing to listen. Number 1. The Baalbek Foundation Stones. In modern-day Lebanon sits a Roman temple complex built on something far more ancient, the Temple of Jupiter at Baalbek. Impressive Roman architecture, massive columns, classical design. But beneath the Roman construction lies something they didn't build: the foundation. 3 limestone blocks form part of the temple base. Each weighs approximately 800 tons. That's 1,600,000 pounds per stone. These aren't the largest blocks at the site. In the nearby quarry sits the Stone of the Pregnant Woman, a single megalith weighing an estimated 1,000 tons, partially cut from bedrock, never moved from the quarry. And next to it lies an even larger stone, discovered in 2014. Estimated weight, 1,650 tons. Here's the problem. The largest mobile crane in the world can lift about 20,000 tons, but that's a specialized offshore crane on a massive vessel. For land-based operations, the limit drops dramatically. Moving a 1,600-ton stone over uneven terrain? Modern engineering firms say it's not feasible with current technology. Yet the 800-ton foundation stones aren't in the quarry. They're in the temple, a quarter-mile away, lifted to a height of 20 feet. Fitted together so precisely you can't slide paper between them. The Romans didn't build this foundation. Roman records describe it as ancient when they arrived. The stones were already in place, already impossibly positioned. So who moved them? Mainstream archaeology suggests ramps, rollers, and massive labor forces. Thousands of workers. Decades of effort. Engineers who've studied the site disagree. The terrain between the quarry and temple is uneven. Rollers would require a prepared roadway capable of supporting 1,600 tons of concentrated weight. That roadway doesn't exist. No evidence it ever existed. Ramps present similar problems. To lift 800 tons, 20 feet, requires a ramp at least 200 feet long to maintain a manageable grade. The structure to support that ramp would be enormous. No traces of it remain. German archaeologist Daniel Lohmann attempted to calculate the logistics. He concluded that moving the stones with Bronze Age technology would require over 40,000 workers just for transport. That assumes perfect coordination, perfect equipment, perfect conditions. A single mistake would be catastrophic. The precision of the placement presents another mystery. The blocks are fitted together with joints so tight that modern stonemasons call them impossible. The surfaces aren't just flat, they're planar to within millimeters across surfaces, measuring 40 feet long. That's precision machining, not primitive stoneworking. What's more, the stones show evidence of being cut with advanced techniques. The quarry marks suggest saws of enormous size, cutting marks that remain uniform across 40-foot spans. Modern stone cutting uses diamond-tipped wire saws. Even those would struggle with blocks this size. Bronze Age tools? The official explanation doesn't address how it's physically possible. Attempts to move the stones using proposed ancient methods have failed repeatedly. In 2008, a documentary crew attempted to move a 10-ton block using ancient techniques. They succeeded after significant effort. 800 tons is 80 times heavier. The scaling doesn't work. Forces don't increase linearly. They increase exponentially. The Baalbek stones remain. Modern technology cannot safely move them. Ancient technology supposedly couldn't either. Yet there they sit, precisely placed, impossibly heavy, silently challenging every assumption about ancient capabilities. Number 2 takes us to Egypt, but not the pyramids. The Osirion at Abydos, a massive granite structure buried beneath the desert, officially attributed to Pharaoh Seti I around 1200 BC. Except the construction doesn't match anything from that period. The Osirion is built from red granite blocks. Many weigh over 100 tons. Some exceed 200 tons. They're fitted together with precision joints. No mortar, just stone on stone. The architectural style is unique. Massive megalithic construction, minimalist design, no hieroglyphs, no decorations typical of the New Kingdom period. It looks far more ancient than Seti's reign. The structure sits 40 feet below ground level. Water from the Nile now fills the lower chambers. The blocks are submerged. This isn't due to flooding. The structure was designed to interact with the water table. Moving 200-ton granite blocks is difficult above ground. Moving them into a 40-foot excavation while maintaining precision placement? That's exponentially more complex. Modern engineers have studied the site. Their assessments are troubling. The blocks would require cranes capable of reaching into a deep excavation while lifting extreme weights. Such cranes exist today. Barely. They didn't exist in 1200 BC. The official explanation involves ramps into the excavation, teams of workers lowering blocks on ropes, precise coordination to prevent disaster. Engineer Christopher Dunn examined the site extensively. His conclusion? The precision of the joints suggests machinery. The weight of the blocks exceeds what rope and wooden equipment could safely control. One mistake would shatter the blocks. One miscalculation would crush workers. Yet, every block was placed perfectly. The granite itself presents questions. The nearest granite quarries are in Aswan, over 100 miles south. Transporting 200-ton blocks that distance would require barges. The Nile was lower in ancient times. Navigation was more difficult. Loading and unloading 200-ton blocks from barges without modern equipment? The logistics are staggering. What's particularly interesting is the wear on the stones. They show evidence of extreme age, erosion patterns inconsistent with the official dating, water erosion suggesting prolonged submersion. Geologist Robert Schoch examined the weathering patterns. His assessment suggests the structure is far older than accepted chronology allows, possibly thousands of years older. That creates problems for the official timeline. If the Osirion predates Seti by millennia, who built it? What civilization possessed the engineering capability? Mainstream archaeology dismisses the geological evidence. The structure must be from Seti's period because that fits the established timeline. The physical evidence suggesting otherwise gets ignored. But the stones remain, 200 tons apiece, precisely fitted at the bottom of a 40-foot excavation, showing signs of extreme age. Modern attempts to move comparable weights into excavations face enormous challenges. specialized equipment, extensive safety protocols, computer modeling to ensure stability. Ancient builders supposedly did it with copper tools and rope. The mathematics don't support it. The engineering analysis questions it, but the official narrative maintains it. Because admitting uncertainty means admitting we don't understand our own history. The Osirion sits in its flooded chamber, its secrets submerged along with the stones. Too heavy for modern equipment to move, too precise for ancient tools to cut, yet undeniably real, undeniably ancient, undeniably impossible by accepted standards. Number 3. The Trilithon of Heliopolis. Most people know Baalbek for the trilithon discussed earlier. But there's another structure that's even more perplexing. The Grand Terrace. This platform sits south of the main temple complex. It's constructed from blocks that make the trilithon look modest. Some blocks exceed 900 tons. That's 1,800,000 pounds. The largest stone in this terrace is estimated at 1,200 tons. It's not in the quarry. It's in the structure. Precisely positioned, elevated, fitted with neighboring blocks. German archaeological teams have studied this terrace extensively. Their documentation includes precise measurements, laser scanning, 3D modeling. Their conclusion? They cannot explain how these stones were moved or positioned with available ancient technology. The terrace blocks are cut from the same quarry as the temple foundations, that quarter-mile distance again. But the terrain is even more challenging. A slope of approximately 7 degrees, moving a 1,200-ton stone up a 7-degree incline? Modern engineers struggle with this calculation. Professor Jean-Pierre Adam, a French architect and archaeologist, attempted to model the logistics. He calculated that moving stones this size would require not just thousands of workers, but perfect equipment made from materials that didn't exist. Wood strong enough to support concentrated 1,200-ton loads doesn't exist. Bronze certainly couldn't handle the stress. Even steel beams would require careful engineering. The Romans used cranes and pulleys for their construction. Roman cranes could lift approximately 10 to 20 tons maximum. The largest Roman crane recorded lifted around 60 tons. Under carefully controlled conditions, 1,200 tons is 20 times heavier than the maximum Roman capability, and the terrace stones predate Roman occupation. What's particularly revealing is the precision. These massive blocks have angled surfaces that fit together perfectly. The angles are consistent, the joints are tight. Creating precise angles on blocks this size requires seeing the entire surface, planning the cuts, executing with consistency across dozens of feet. Modern stone cutting for blocks this size uses computer-controlled saws, wire saws with diamond abrasives, laser guidance for precision. Ancient builders supposedly used copper chisels and stone pounders. The wear marks on the stones tell a different story. They're consistent, uniform, deep. They suggest cutting tools moving at high speed with tremendous force. That's not manual stoneworking. That's mechanical cutting. When documentary teams have asked modern stone-cutting companies to bid on moving these stones, the companies refuse. The liability is too high. The equipment requirements too specialized. The risk of failure too great. If modern companies won't attempt it, how did ancient builders succeed? The terrace sits there. 1,200-ton blocks positioned with precision, fitted with mathematical accuracy, elevated above ground level. Modern archaeology dates the terrace to around 300 BC, Phoenician construction, but the architectural style doesn't match anything else. Phoenician, the scale exceeds anything they built elsewhere. It looks like the work of a different civilization entirely, one with capabilities we don't understand. The Grand Terrace of Heliopolis stands as evidence of lost knowledge, engineering techniques we can document but not explain, capabilities we can measure but not replicate. The stones are too heavy for our best equipment, too precisely cut for our understanding of ancient tools, too impossible for the accepted timeline. But there they are, undeniable, unmovable, unexplainable by conventional archaeology. The evidence speaks clearly. We're listening selectively. Number 4. The Yangshan Quarry Stone. In China's Jiangsu province lies an abandoned quarry. Inside sits the largest worked stone ever discovered, the Yangshan Quarry Stone, cut during the Ming Dynasty around 1400 AD, intended for a memorial stele. It was never moved from the quarry. The stone measures approximately 100 feet long, 40 feet wide, 40 feet thick. Engineers estimate its weight at 31,000 tons. That's 62 million pounds. For context, the largest stone moved in modern times is the Thunderstone, moved in 1770 to serve as the pedestal for the bronze horseman statue in St. Petersburg. That stone weighed 1,500 tons. It required months of preparation, hundreds of workers, specialized equipment designed specifically for the task. The Yangshan stone is 20 times heavier. The Ming Dynasty had sophisticated engineering. They built the Forbidden City, the Great Wall expansions, massive irrigation projects. They understood architecture, mathematics, and logistics. Yet they abandoned this stone in the quarry, incomplete, never moved. The official explanation is that the emperor died. The project was cancelled. The stone left where it was cut. But here's what that explanation misses. The stone was already cut. The hard work was done. Carving 31,000 tons of stone from bedrock is far more difficult than moving it. If they could cut it, why couldn't they move it? The answer appears obvious. They realized movement was impossible with their technology. Modern engineers who've studied the site agree. Moving this stone would require equipment that doesn't exist. The largest cranes in the world couldn't lift it. The strongest transport vehicles couldn't carry it. Professor Wang Wenjie from Nanjing University conducted a detailed analysis. His team calculated the forces involved, the structural requirements, the logistics of transport. Their conclusion was unambiguous. Moving the Yangshan stone exceeds current technological capabilities, not just Chinese capabilities, global capabilities. The stone would need to be transported approximately 25 miles to reach Beijing. That's over uneven terrain, through areas that flood seasonally, across rivers. Building a roadway capable of supporting 62 million pounds of concentrated weight would be a massive project itself. The roadway would need foundations, bridges, engineering as sophisticated as the transport operation. No evidence suggests such a roadway was ever attempted. What makes this significant is the timing. 1400 AD isn't ancient history. We have detailed records from the Ming Dynasty, engineering treatises, construction manuals, administrative documents. None of them describe technology capable of moving 31,000-ton stones, yet the stone was ordered, cut from bedrock, shaped into a rectangular form. The workers clearly believed it could be moved. What knowledge was lost between the planning and execution? What techniques did earlier Chinese dynasties possess that the Ming had forgotten? China's ancient history includes structures that suggest advanced stoneworking capability, the massive stone platforms at some imperial sites, the precision of certain ancient foundations, evidence of techniques that aren't documented in surviving texts. The Yangshan stone sits in its quarry 6 centuries later, slowly eroding, a monument to ambition exceeding capability, or evidence that capability once exceeded what we can now achieve. Modern China could cut a stone this size. Diamond saws, modern quarrying equipment, computer-controlled precision. But moving it? Engineers shake their heads. Not possible. Not safe. Not with existing equipment. The Ming Dynasty believed they could. They invested enormous resources in cutting it. Either they were wildly optimistic, or they knew something we've forgotten. The stone remains. 62 million pounds of worked granite. Too heavy to move in 1400. Still too heavy to move today. A silent reminder that progress isn't always forward. Sometimes knowledge is lost. Sometimes capabilities disappear. The Yangshan stone proves it. Number 5 takes us back to Egypt. The Colossi of Memnon. 2 massive statues sit on the west bank of the Nile near Luxor. They depict Pharaoh Amenhotep III. They're carved from single blocks of quartzite sandstone. Each statue weighs approximately 720 tons. They stand 60 feet tall. They were transported from quarries near Cairo, that's over 420 miles north. Moving 700-ton statues over 400 miles of ancient Egypt presents challenges modern logistics companies call impossible. The Nile provided transport for most of the journey, but quartzite is brittle. A stone this size on a barge creates enormous stress. Any instability could crack the statue, destroy years of work. Building a barge capable of carrying 700 tons in ancient times requires engineering we barely understand. The barge itself would be massive, requiring hundreds of tons of timber, specialized construction, waterproofing beyond typical Egyptian capability. No remains of such barges have been found. We have wrecks of normal Egyptian boats, trading vessels, fishing boats, nothing approaching the scale needed for these statues. The statues aren't just large, they're precisely carved. Details remain visible after 3,400 years. Facial features, inscriptions, decorative elements. Carving details into 700 tons of quartzite requires tools harder than the stone. Quartzite ranks 7 on the Mohs hardness scale. Bronze ranks 3. Copper ranks 2.5 to 3. The official explanation suggests copper tools with quartz sand as an abrasive. Thousands of hours of patient work, metallurgist Dinas Stock attempted to replicate ancient carving techniques. He used copper tools and sand. Progress was extremely slow. The copper wore away faster than the stone. Efficiency was minimal. Scaling that process to carve 700-ton statues, Stock estimated it would require decades, thousands of workers, constant replacement of tools. The mathematics become questionable. The labor investment seems disproportionate to the result. Yet the statues exist, precisely carved, successfully transported, erected at their destination. Erecting a 700-ton statue requires tilting it upright. Modern engineers use cranes and hydraulics for such operations. Extreme precision is necessary. Any miscalculation results in catastrophic failure. Ancient Egyptians supposedly used ramps and counterweights, teams of workers pulling ropes, gradual tilting through earth embankments. Engineer Maury Garib from Caltech studied ancient obelisk raising techniques. He conducted scale experiments. His conclusion? Raising truly massive stones using rope and manual labor becomes exponentially more dangerous as weight increases. At 700 tons, the margin for error becomes microscopic. A rope failure would be deadly. A miscalculation would destroy the statue. Yet both statues were raised successfully, positioned precisely, aligned perfectly. Modern attempts to move stones of comparable weight face enormous obstacles. When Italy gifted a 700-ton obelisk to the United States in 1925, transportation required specialized equipment, a custom ship, massive cranes, months of planning. That was with 20th century technology, steel cables, diesel engines, hydraulic lifts. Ancient Egypt supposedly accomplished it with bronze and rope. The colossi have stood for over 3 millennia. They've survived earthquakes, floods, weathering. They've outlasted the civilization that built them. But they haven't survived without damage. One statue was damaged in an earthquake around 27 BC. Roman repairs are still visible. That repair work provides interesting evidence. The Romans, with their advanced engineering, didn't attempt to work with stones of this scale. Their repairs are comparatively modest, using smaller blocks, more conventional techniques. If the Romans, with their sophisticated construction capability, avoided working with 700-ton stones, what does that say about doing so in the Bronze Age? The colossi of Memnon stand as silent giants, too heavy for modern equipment to move safely, too precisely carved for accepted ancient tools, too successfully transported for conventional logistics. Their evidence, physical evidence, documented, measured, undeniable, evidence of capabilities we struggle to explain, techniques we cannot replicate, knowledge that was lost when Egypt fell. The statues remain. The questions remain. The answers remain, hidden in methods we've yet to rediscover. Number 6. The Ramesseum stones. Also in Luxor sits another monument to Ramesses II. The Ramesseum, his mortuary temple, impressive architecture, grand scale, typical Egyptian grandeur. At the entrance once stood a colossus of Ramesses, carved from a single block of granite. The statue weighed approximately 1,000 tons. It's no longer standing. It fell during an earthquake. The fragments still lie scattered across the temple courtyard. What's remarkable isn't that it fell. What's remarkable is that it was ever raised. The statue was transported from Aswan, the granite quarries over 130 miles south. That's a substantial journey. Moving 1,000 tons by water requires a barge of extraordinary size. Dutch engineer Franz Lohner attempted to calculate the requirements. His analysis suggests a barge approximately 150 feet long, 40 feet wide, made from massive timbers, requiring specialized construction techniques. No evidence of such barges exists in the archaeological record. The statue wasn't just transported, it was erected at the temple entrance, raised from horizontal to vertical. A 1,000-ton stone tilted upright with Bronze Age technology. Modern crane operations for stones this size require extensive preparation, computer modeling, stress analysis, multiple cranes working in coordination. The largest mobile crane used in archaeological work can lift about 500 tons under ideal conditions on level, reinforced ground. With weeks of preparation, 1,000 tons exceeds that capacity significantly. The ancient Egyptians supposedly used ramps and levers, earth embankments built around the statue, gradual tilting as workers pulled ropes. Engineer Mark Lehner has proposed various methods. He's conducted experiments with smaller obelisks. His work demonstrates that tilting stones using ancient techniques is possible. At smaller scales, the forces involved in tilting a 1,000-ton statue are exponentially greater. Rope strength becomes critical. A single failure would be catastrophic. The statue would crash down. Workers would be crushed. Years of work destroyed. Yet the statue was successfully raised. It stood for centuries. Only an earthquake brought it down. The fallen fragments reveal interesting details. The granite is incredibly hard. The carving is precise. Details remain visible in the weathered stone. Creating that precision on a block this size requires seeing the entire work, planning the proportions, executing with consistency across 40 feet of height. Modern sculptors working at this scale use scaffolding, power tools, computer models, multiple artists working from detailed plans. Bronze Age sculptors supposedly used copper chisels and stone pounders. Manual labor. No overall view of the work until completion. The precision achieved seems inconsistent with the tools available. What's particularly interesting is the base of the statue. The fragments show it had a precisely cut flat bottom. The surface is planar across several square yards. Creating a flat surface on the base of a 1,000-ton statue requires flipping the stone, working from all sides, multiple times during the carving process. Flipping a 1,000-ton stone during carving? Modern stone workshops won't attempt that. The risk of cracking the stone is too high. The equipment requirements too extreme. Ancient sculptors supposedly did it routinely. The Ramesseum statue fragments lie where they fell. Modern authorities have discussed moving them, reconstructing the statue, or relocating the pieces for preservation. Those discussions stalled when engineers provided cost estimates. The conclusion was consistent. Moving these fragments with modern equipment would be extremely difficult and expensive. Full reconstruction would be nearly impossible. If we struggle to move the fallen pieces, how did ancient builders move and erect the intact statue? The fragments provide physical evidence, documented weight, measured dimensions, observed precision, evidence that Bronze Age Egypt accomplished what modern engineering finds challenging. Either our understanding of ancient capabilities is fundamentally flawed, or techniques existed that aren't preserved in the historical record. The Ramesseum stones suggest the latter strongly. Number 7. The Western Stone at Jerusalem. Beneath the streets of Jerusalem's Old City lies the Western Wall Tunnel. This tunnel runs along the western wall of the Temple Mount. It exposes Herodian construction from around 20 BC Deep in this tunnel sits a stone that defies explanation: the Western Stone. A single limestone block, measuring 44 feet long, 10 feet high, 14 feet deep. Engineers estimate its weight at approximately 570 tons. This stone isn't on ground level. It's positioned high in the wall, approximately 50 feet above the street level of Herod's time. Moving a 500-ton stone is difficult. Lifting it 50 feet in the air? That's exponentially more complex. The stone is part of a retaining wall. It supports enormous weight from the structures above. The Temple Mount platform sits on these walls. The engineering must be precise. Any instability would be catastrophic. Herod had substantial resources: Roman engineering expertise, thousands of workers, access to advanced construction techniques for the period. Yet even by Roman standards, this stone is extraordinary. Roman engineering manuals describe their largest cranes and lifting devices. The specifications are detailed. The maximum weights are documented: approximately 60 tons. Under ideal conditions, the Western Stone weighs nearly 10 times that. No contemporary accounts describe how it was moved or positioned. Josephus, the Jewish historian who documented the temple's construction, mentions the massive stones, but he doesn't explain the methods. That silence is interesting. If conventional methods were used, why not document them? Romans typically recorded their engineering achievements. The precision of the placement raises additional questions. The stone fits perfectly in the wall. The courses above and below align exactly. The wall faces are planar. This isn't rough stonework. This is architectural precision on a massive scale. Modern engineers who've studied the Western Wall express confusion about the construction methods. The stones are too large for documented Roman equipment. The precision exceeds what manual stone working should achieve. Dr. Lean Rittmeyer, an archaeologist specializing in Temple Mount research, has documented the construction extensively. His conclusion? The engineering represents the pinnacle of ancient capability, but he acknowledges uncertainty about specific methods. The tools and techniques that could move 500-ton stones to precise positions 50 feet in the air aren't clearly understood. What makes this more intriguing is the foundation beneath these stones. The Western Wall goes deep. Archaeological excavations revealed that it extends over 60 feet below current street level. The lower courses also contain massive stones, some exceeding 100 tons, positioned underground with the same precision as the visible sections. Building underground with stones this size presents unique challenges. Working in excavations, limited space, restricted access, all while maintaining precision. Modern construction in confined spaces uses specialized equipment: compact cranes, hydraulic lifts, careful planning. Ancient builders supposedly used ramps and manual labor in underground chambers. The logistics become increasingly difficult to explain. The Western Stone remains where Herod's builders placed it, 2,000 years later, still supporting the Temple Mount, still defying easy explanation. Modern preservation efforts avoid disturbing these massive stones. The risk is too high, the equipment requirements too specialized. If moving them today is too risky, how was it accomplished 2 millennia ago? The stone weighs 570 tons. That's documented. It sits 50 feet above ancient street level. That's measured. It's precisely fitted into a wall that survived 2,000 years. That's observable. Those are facts, not speculation. Physical evidence anyone can examine in the Western Wall tunnel. Evidence that suggests ancient engineering capabilities we don't fully comprehend. Techniques that aren't preserved in historical records. Methods that exceeded the documented technology of the time. The Western Stone stands as silent testimony, too heavy for contemporary equipment, too precisely placed for simple explanations, too real to dismiss. Number 8 takes us to Peru. The stone walls of Sacsayhuaman, overlooking Cusco, sits one of the most perplexing megalithic sites in the Americas. Sacsayhuaman, massive stone walls, built with blocks that dwarf anything in North America. The largest stones exceed 300 tons. Some estimates go higher, 400 tons or more. These aren't simple rectangular blocks. They're complex polygonal shapes, fitted together like three-dimensional puzzles. The joints between stones are so precise that paper won't fit between them. The walls have survived 500 years of earthquakes. Spanish colonizers tried to dismantle them for building material. The massive stones defeated their efforts. Only the smaller stones could be removed. The largest blocks remain, precisely fitted, immovable. The official attribution is Incan construction. Built in the 15th century under the reign of Pachacuti, the Inca had sophisticated engineering. They built Machu Picchu, extensive road networks, impressive architecture. But Sacsayhuaman is different. The construction style doesn't match later Incan work. The scale exceeds anything else they built. Local tradition says the Inca found these walls already in place. They conducted repairs, added their own construction, but the massive megalithic core predates them. That tradition gets dismissed as myth, despite physical evidence supporting it. The stone, working at Sacsayhuaman, shows characteristics that puzzle modern stonemasons. The surfaces aren't just smooth. They're curved, complex three-dimensional shapes that interlock with neighboring stones. Creating these shapes requires seeing multiple stones simultaneously, understanding how they'll fit together, executing with precision across hundreds of tons of rock. Modern computer-aided design could model this, but execution would require CNC stone-cutting machines, computer-controlled tools carving three-dimensional curves into solid rock. The Inca supposedly used stone hammers, bronze chisels, manual labor. The mathematics don't support that explanation. The time investment would be astronomical. The precision, unachievable with hand tools. Engineer Jean-Pierre Pratzen attempted to replicate Incan stoneworking techniques. He used documented Incan tools, stone hammers, bronze implements. He could shape stones, but the precision he achieved was far below what's observed at Sacsayhuaman. The curves weren't as exact, the fits weren't as tight, and he was working with much smaller stones. Tons, not hundreds of tons. The transportation question remains unanswered. The stones came from quarries miles away. The route includes steep terrain, valleys, slopes. Moving 300-ton stones over this terrain would require roads built specifically for the purpose, foundations capable of supporting extreme weights, engineering as sophisticated as the walls themselves. No evidence of such roads has been identified. The stones somehow made the journey, but the method remains unclear. Positioning these massive polygonal blocks requires extreme precision, not just horizontal placement. Vertical positioning as well. The walls are stepped, stones at different heights, all interlocking perfectly. Modern engineers attempting to position irregular 300-ton stones would use multiple cranes, computer guidance, extensive trial and error with three-dimensional modeling. Ancient builders supposedly eyeballed it, got it right the first time. With every stone, the probability of that seems vanishingly small. What's particularly interesting is the weathering on the stones. Some blocks show far more erosion than others. Different weathering patterns suggest different ages. The most massive blocks show the most weathering, suggesting they're the oldest, predating the construction attributed to the Inca. That observation gets dismissed by mainstream archaeology. All the blocks must be contemporary because that fits the timeline. But the physical evidence suggests otherwise. Sacsayhuaman has survived earthquakes that leveled Spanish colonial buildings in Cusco. The precise fitting of the massive blocks provides structural integrity. The stones move slightly during seismic events, then settle back into position. Modern seismic engineering calls this sophisticated design, earthquake-resistant construction that rivals modern base isolation techniques. The Inca are credited with this engineering wisdom, but if they possess such knowledge, why doesn't it appear in their other construction? The massive walls of Sacsayhuaman remain, 300-ton stones fitted with impossible precision. Surviving earthquakes through engineering, we struggle to replicate. Too complex for accepted ancient tools, too precisely fitted for manual stoneworking, too massive for contemporary transportation methods. But undeniably there, undeniably ancient. undeniably impossible by conventional archaeological explanations. Number 9. The Lateran Obelisk. In Rome stands the tallest obelisk in the world. The Lateran Obelisk, originally from Karnak in Egypt, carved during the reign of Thutmose III, around 1400 BC. It's a single piece of red granite, 105 feet tall, weighs approximately 450 tons. The Romans moved this obelisk from Egypt to Rome in the 4th century AD. Emperor Constantius II ordered its transport in 357 AD. The journey took months. Custom barges, thousands of workers, engineering that pushed Roman capabilities to their limit. That was moving an existing obelisk. The Egyptians had to create it first. Carving a 100-foot obelisk from solid granite requires removing it from bedrock. The Aswan quarries show evidence of obelisk creation. Channels cut around the obelisk shape, careful splitting from the underlying rock. Then comes the challenge. A 450-ton stone, lying horizontally, must be moved to transportation. Modern quarrying operations for stones this size use mobile cranes, heavy equipment, precision planning. Bronze Age Egypt supposedly used rollers and sledges, manual labor, rope. The physics become questionable at this scale. Rolling a 450-ton stone requires rollers that can support the weight without fracturing. Wood strong enough for this application is rare. The distribution of weight becomes critical. Transportation to the Nile required moving the stone several miles, then loading it onto a barge. A 450-ton load on a wooden barge creates enormous structural stress. Egyptian barge construction used wood joinery and rope. No metal fasteners, no modern adhesives. The hull must support 450 tons without flexing excessively. Flexing causes cracks in granite, cracks that would ruin years of carving. Yet the obelisk made the journey intact, down the Nile, hundreds of miles, successfully delivered to its destination. Then comes the most impressive part, erecting it. Tilting a 450-ton stone from horizontal to vertical is an extreme engineering challenge. The center of gravity shifts during the process. The forces involved are enormous. Any miscalculation results in catastrophic failure. The Romans, with their advanced engineering, found this task extraordinarily difficult. Accounts of moving obelisks describe complex operations, specialized equipment, multiple attempts, sometimes failures. And the Romans had steel, sophisticated pulleys, advanced mathematics. Bronze Age Egyptians supposedly erected these obelisks routinely, with copper tools and rope. The mathematical calculations for such operations require understanding leverage, force distribution, and center of gravity. Advanced concepts for any era. The precision of obelisk placement adds another layer of complexity. These monuments were positioned exactly, aligned to cardinal directions, centered in specific locations. Lowering a 450-ton stone into its final position with millimeter precision requires control that modern cranes struggle to achieve. Ancient builders supposedly achieved it with ramps and ropes. Engineer Mori Garib conducted experiments with scale models. His findings suggest that tilting operations become exponentially more dangerous as scale increases. At 450 tons, the margin for error becomes microscopic. Yet multiple obelisks of this scale were successfully erected. Not just one, multiple monuments, all successfully created, transported, and raised. The Lateran Obelisk stands in Rome as testament to this achievement. Moved by the Romans, created by the Egyptians, surviving over 3,500 years. Modern engineers look at it with respect and puzzlement. We can move it now, barely. With specialized equipment, extensive planning, enormous expense. Bronze Age Egyptians supposedly did it routinely, with fraction of the resources. Either our understanding of ancient capabilities is severely underestimating them, or techniques existed that aren't documented. The obelisk stands, 450 tons of carved granite, precisely positioned, successfully transported across continents and centuries. Evidence that ancient engineering achieved what we barely can. using methods we don't fully understand, accomplishing tasks we'd hesitate to attempt. The stone speaks clearly. We're listening selectively. Number 10. The Stone of the South. Back to Baalbek. Because the mysteries there aren't finished. Beyond the stone of the pregnant woman lies another megalith. The Stone of the South, discovered in 2014 by a German archaeological team. This is the largest worked stone block ever discovered, bar none. The measurements are staggering. 64 feet long, 19 feet wide, 18 feet thick. Weight estimates vary based on the density of the limestone. Conservative calculations place it at 1,650 tons. Some estimates go as high as 2,000 tons. That's over 3 million pounds. To put this in perspective, the largest stone successfully moved by humans in modern times is about 1,500 tons, the Thunderstone in Russia. That operation in the 18th century was considered an extraordinary engineering feat. It took years, required custom equipment designed specifically for that purpose. The Stone of the South is larger, and it was cut using ancient tools. The stone was never finished. It remains partially attached to the bedrock. The workers abandoned it mid-project. Why? The accepted explanation is that the project was cancelled. Resources diverted elsewhere. The stone left where it lay. But that doesn't quite make sense. Cutting a stone this size from bedrock represents enormous investment. Months or years of labor, thousands of worker hours, significant resources. Abandoning it suggests the workers realized something. Movement was impossible, or far more difficult than anticipated. The German team that discovered it conducted extensive analysis, laser scanning, photogrammetry, precise measurements. They documented everything meticulously. Their published findings carefully avoid speculating about movement methods. They describe the stone, note its size, mention it was never moved. They don't explain how ancient builders ever expected to move it, because modern engineering has no good answer. The logistics of moving 2,000 tons are extreme. The world's largest mobile cranes can lift around 20,000 tons. But that's specialized offshore equipment, not applicable here. Land-based crane operations max out around 5,000 tons, and that's with multiple cranes working together on prepared, reinforced surfaces, under controlled conditions. Moving 2,000 tons over ancient terrain? Modern engineering firms won't bid on that project. The route from the quarry to Baalbek includes slopes, uneven ground, obstacles. Moving 2,000 tons over this route would require building infrastructure comparable to the transport operation itself. Some researchers suggest the stone was meant to be broken into smaller pieces after removal from the quarry, transport in segments rather than as a single block. But the stone shows no evidence of planned segmentation, no cutting marks indicating where breaks were intended. It appears designed as a single megalith. Why cut a stone this size if the plan was to break it up? Why not cut smaller stones from the beginning? The precision of the cutting adds to the mystery. The surfaces are flat, the edges relatively straight. This wasn't crude rock removal. This was careful stoneworking. Creating flat surfaces on a 2,000-ton stone requires seeing the entire work, checking for straightness across 60 feet, maintaining consistency. Modern stone working at this scale uses surveying equipment, laser levels, computer measurements. Ancient stone workers supposedly used string lines and manual tools. The Stone of the South remains in the quarry, a monument to ambition, or evidence of lost capability. It's the largest stone humans ever attempted to work. That's documented, measured, verified by multiple academic teams. It was never moved. That's also clear. Whether it was never moved because the project was cancelled or because movement proved impossible remains an open question. But the stone itself is evidence. Evidence of ancient stoneworking at scales we struggle with today. Evidence of planning that envisioned moving 2,000-ton blocks. Evidence of capabilities that aren't fully explained by conventional archaeology. The Stone of the South lies in its quarry, partially cut, abandoned, the largest megalith project ever attempted. Modern archaeology says they intended to move it but never did. The stone suggests they tried to move it and couldn't. Which interpretation fits the evidence better? The one that assumes ancient capabilities exceeded ours, or the one that admits ancient ambition sometimes exceeded ancient capability? The stone doesn't answer. It just lies there. 2,000 tons of cut limestone. Too large for modern equipment. Too precisely worked for ancient tools. Silent testimony to a mystery we've yet to solve. 10 megaliths. 10 stones that modern engineering admits are too heavy to move safely with current technology. From the 800-ton foundation stones of Baalbek to the 2,000-ton stone of the south left in its quarry. From the precision-fitted 300-ton polygonal blocks of Sacsayhuaman to the 450-ton obelisks of Egypt, the pattern is undeniable. Ancient builders worked with stones at scales that push or exceed modern capabilities. These aren't mysteries because the stones disappeared. They're mysteries because the stones remain. Precisely positioned, successfully transported, expertly carved. Mainstream archaeology explains these achievements through ramps, rollers, and massive labor forces. Thousands of workers, decades of effort, simple tools applied with patience and skill. Modern engineers who've studied these sites express skepticism. The mathematics don't support it. The logistics are questionable. The precision seems unachievable with proposed methods. Attempts to replicate ancient megalith movement using documented techniques consistently fail at scale. Small demonstrations work. Multi-ton stones can be moved with effort. But hundreds of tons? The scaling doesn't work. Forces increase exponentially. Yet the stones exist. They were moved. They were positioned. They were carved with precision that rivals machine work. What techniques did ancient builders possess that we've lost? The evidence suggests sophisticated understanding of engineering, materials, and physics. Knowledge that either wasn't recorded or was deliberately suppressed when civilizations fell. The Romans couldn't work with stones on the scale of Baalbek's foundations. They built on top of them. They didn't attempt to recreate them. The Spanish conquistadors couldn't dismantle Sacsayhuaman. They gave up. The stones were too massive, too well-fitted. Modern engineering firms refuse to bid on moving these megaliths. The liability is too high. The risk of failure too great. The equipment requirements too extreme. If we can't move them now, how are they moved then? 3 possibilities present themselves. First, ancient peoples possessed engineering techniques we've yet to rediscover. Methods not preserved in historical records. Knowledge lost when civilizations collapsed. Second, our understanding of ancient capabilities is fundamentally flawed. We're underestimating their sophistication, dismissing evidence that doesn't fit comfortable narratives. Third, some of these structures predate the civilizations we attribute them to. The Inca found Sacsayhuaman already there. The Romans found Baalbek's foundations in place. The techniques that created them were already lost to history. That third possibility is the most disruptive. It suggests civilizations existed before recorded history. Societies with engineering capabilities that exceeded what came after. Cultures that built monuments we can barely comprehend. The megalith evidence supports this possibility strongly, but accepting it requires rewriting history, acknowledging that human civilization might be older and more sophisticated than accepted timelines allow. That's a paradigm shift archaeology resists. Despite physical evidence literally carved in stone, the megaliths remain undeniable, unmovable, unexplained by conventional theories. They're not asking us to believe mythology. They're asking us to explain physics, to demonstrate how hundreds of tons were moved, to show how precision was achieved, to replicate what ancient builders accomplished. We can't. Not with their supposed tools, not with our modern equipment, not with any method that fits accepted capabilities. The stones challenge everything we think we know about ancient engineering. They demand explanations we can't provide. They present mysteries we've barely begun to investigate. 10 megaliths, 10 questions, 10 pieces of evidence that ancient peoples achieved what we struggle to imagine. The evidence is stone, Solid, measurable, real. What we believe about ancient capabilities is a choice, but the stones don't care what we believe. They'll stand there regardless. Too heavy to move, too precisely placed to dismiss, too impossible to ignore. The question isn't whether these megaliths exist. They do. The question is whether we're willing to admit we don't fully understand how they came to be. Ancient engineering achieved the impossible. The stones prove it. The rest is acknowledging what they teach. Human history is older, stranger, and more sophisticated than the official narrative allows. The megaliths have been saying this for millennia. Maybe it's time we started listening.